So welcome students in the series of kinematic equation for uniformly accelerated motion of the chapter motion in a straight line, which is important for CBSE NEET as well as for the IIT JEE examination. So I'm Sapna Suli, your mentor. Let's begin the first topic, which is kinematic equation for uniformly accelerated motion. Student, kinematic equation for uniformly accelerated motion consisting like few terms. Here we are I'm representing a graph to you. As you can see, the particle is initially at rest till the point B, but after that it start to do uniformly motion, and the body is accelerated. As you can see, the velocity is continuously changing. It's the position of a time. So at different location of a time, the particle position is different. So let us consider the terms displacement x, time taken t, initial velocity v0, final velocity v, acceleration a. The three kinematic equations for a uniformly accelerated motion are: final velocity v is equals to v0 plus at, displacement x is equals to v0 t plus half at square, final velocity v square is equals to u square, or we can say v naught square plus 2ax. Let us derive the first equation. So the same graph we have, as we can see, in this graph, earlier we heard about the slope, and slope of vt time graph is described by the tan theta, which is acceleration. So acceleration is a perpendicular divided by base. Perpendicular is nothing but the changement in the velocity and the time which is taken by in this duration. So changement is a very small in kind. That's why we are taking here dv. So a is equals to dv by dt, and dv is a small change which we are taking here, final velocity minus initial velocity. Changement in the final velocity minus of initial velocity divided by time. From here, we can get the equation like at is equals to v minus v naught, or we can write as a v is equals to v naught plus at. This is equation number 1. Let us derive the second equation. So x is equals to ut plus half at square. Instead of a vu, I am taking v naught. So again the graph is here. OA is equals to BD as in the graph, and OB is equals to DA. Okay, the value of OB is equals to V naught, and CD is equals to BF is equals to OF minus OB, which comes V minus V naught. Since we know that A is equals to V minus V naught by T, so V minus V naught is equals to AT. And from this, displacement is equals to X is equals to area of OACB. Area of OACB can be determined by the two factors OADB plus area delta BDC. So OA into OB plus half times of OA into CD. X is equals to V naught T plus half T V minus V naught. X is equals to V naught T plus half T into AT. That comes x is equals to v naught t plus half at square is the first point. Second equation. Now, from here we can say It's the proof of second equation of motion. Area of OADB is the area of a rectangle. This is the area of rectangle. And BDC is the area of a triangle. So we know that area of a rectangle is length into width, and this will be half into base into height. So from here we taken this terms. I hope you understand. Secondly and the last, we are just proving this value. V square is equals to V naught square plus 2ax from the first equation, that V is equals to V naught plus at. From here we can take out the value of a t, which is a V minus V naught by a. From second, we can put like x is equals to V naught t plus half at square. What we are going to do, we just put this value of t in this equation and get the value x is equals to V naught by a minus V naught square by a plus a by 2 v square plus V naught square minus 2v naught by a square. From here we get the value in this form, and after a bit of calculation we receive this value in this form. As you can see, this both terms will be cancelled out and we get this equation. So final result what we receive, that x is equals to V naught V square minus V naught square by 2a, which will be V square is equals to V naught square plus 2ax. Now let's move on the some multiple choice question. Kinematic equation are applied for uniformly dash motion. Options: circular, retorted, decelerated, or accelerated. The correct answer for this question is accelerated motion. Now the derivation of equation of motion using calculus method. So this is the derivation of equation of motion using calculus method. Let us suppose an object which moves in a straight line with uniform acceleration a. The initial velocity of the object is u, which is initially at 0 time interval, that will be a moving, and v is its initial velocity after time interval. After time interval t is equals to 1. Velocity time relation, a is equals to change in velocity divided by time, and a gives dv by dt, where dv is the change in velocity in time dt. So dv is equals to a dt. Integrating both sides within the condition, we get u to v dv is equals to a 0 to t dt, which comes v 0 to t is equals to a t minus 0. Hence, after putting the upper limit and the lower limit, we get the final result, which is a v is equals to u plus et. Hence, we prove this. But in the vector form, in this vector from this within the condition, we get vector v is equals to vector u plus vector at. Acceleration is also a vector quantity. Now, the second term is a distance-time relation. Let us suppose an object moves in a straight line with uniform acceleration a. At instant t, the distance traveled by the object in the time interval dt is ds. Then instantaneous velocity of the object is given by v is equals to ds by dt, or ds is equals to v dt, which comes the value u plus at dt, or ds is equals to u dt plus at dt. From here we can say, integrating both sides within the condition, we get 0 to s ds is equals to u 0 to t dt plus a 0 to t t dt. After integration, we get s is equals to ut plus a t square by 2 0 to t. And here s is equals to ut plus half at square. Now in vector form, this equation can be written as s is equals to ut plus half at square. And velocity displacement relation, a is equals to dv by dt. If we just do simply cross multiplication by the terms ds by dt, So we get dv by ds is into v. Now with both side we taking integration symbol, and what is the mean of ds by dt? Is presenting over here, that is a rate of change of displacement. And the rate of change of displacement is nothing but velocity. So ADS is equals to VdV we are taking, and we are taking integration both side within the condition. So we will get A, because acceleration is a constant in this relation, 0 to SDS, and velocity is a variable. How we recognize, students, if you are facing problem to recognize what kind of a term is a constant and what is actually the variables term. So the terms which is comes with this D, that is in variable, we can't take out from this integration sign. As you can see, v is related with this dv, so this is a variable, means we can say v is variable and here s is a variable, but a is not related with the s, so here s is we are taking as a constant. Hope you are clear, students. If there is any doubt, you can ask in the chat or a comment section also. So AS is equals to V square by 2. If we put the upper limit and a lower limit, we get the value 2AS is equals to V square minus U square. From here we get V square minus U square is equals to 2AS. And in vector form, so we can say in vector, from this equation can be written as a vector V dot vector V is equals to vector U dot vector U plus 2 vector A dot vector S. So students, this is all about for today's class. I hope you enjoy the class session. And again, if you have any doubt, you can ask in the comment section. Till that, take care and thank you for watching this video.